Good morning, Year 6. It's Wednesday, and some of you might have realised that actually today, Wednesday the 13th of May, should be the day that Year 6 are sitting their arithmetic and their first reasoning paper. So it should be SATS Math Day today. I know you've all been working really hard on your arithmetic and keeping those reasoning skills going from talking to the teachers. So I'm going to go through the answers to our reasoning with you today. So it's day 3 of week 6, and here are the questions that we had to look at for week 6. So the first question, Finley is playing a big game of snakes and ladders. On his board there are 13 squares in each row and 15 squares in each column. How many squares are there on the board altogether? So I'm going to think about what a snakes and ladders game looks like. So quite often you'll see a snakes and ladders game with 10 rows of 10 columns, and we know to work that one out we multiply 10 by 10 and we've got 100 squares. So let's think about what Finley's board looks like, because it's not a traditional snakes and ladders board. So he's got 13 squares in each row and 15 squares in each column. I haven't drawn the squares, I'm not that technologically advanced. So if I was multiplying 10 by 10 to get 100, I'm going to multiply 15 by 13 to work out how many squares Finley's got. So my calculation is going to be 15 multiplied by 13. Now, it's always good to estimate how big we think the answer is going to be. It's going to be bigger than a traditional snakes and ladders board, and that would be 10 by 10, which is 100. So I'm expecting an answer bigger than 100. If I get less than 100, I need to check my calculation. So let's work through this. The first thing I'm going to do is 3 multiplied by 5, which gives me 15. So a 5 in the ones and then a 1 in the tens. Now I'm doing 3 multiplied by 1 is 3. Add the 1 underneath is 4. And we all know before we move on to multiplying by the tens, we put a 0 as a placeholder. Now I'm going to do 1 multiplied by 5 is 5, and 1 multiplied by 1 is 1. So my total number of squares, when I add them together, is 195. And I said earlier that I expected it to be bigger than 100 because I'm multiplying 2 numbers that are bigger than 10 together. I'm happy with that. 195 squares on his snakes and ladders board. Question 2. Ava thinks of 2 prime numbers. She adds the 2 numbers together. Her answer is 24. Write all the possible pairs of prime numbers Ava could be thinking of. Now, there's different ways of approaching this. What you could do is randomly think of a prime number and think, right, what do I add to make 24? Is that a prime number? But I'm going to model working systematically. So the first thing I'm going to do is write down all of my prime numbers, and I'm going to try them in order. And I'm going to think out loud as I do that. So 2 is a prime number, but what do I add to 2 to make 24? I add 22. And 22 is not a prime number because it's even and therefore a multiple of 2. So I'm not using the 2. 3 is a prime number. What do I add to 3 to make 24? 3 add 21 makes 24, but 21 isn't a prime number. Remember, I'm looking for 2 prime numbers. 21 is 3 times 7, so 3 is not an option. 5 is a prime number because it only has 1 in itself as factors. What do I add to 5 to make 24? Well, I add 19, and 19 is also a prime number. So my first pair that I'm going to write down are 5 and 19. That's one of the pairs she could be thinking of. So moving on, my next prime number after 5 is 7. So what do I add to 7 to make 24? Well, I know 7 adds 7 is 14. So 7 adds 17 is 24. And 17 is a prime number. So I can write down 7 and 17 as my next ones. So I've used 5, I've used 7, now I'm going to check 9. What do I add to 9 to make 24? I add 15. Now 15 is not a prime number, it's not in that list. Another reason 15 is not a prime number is because it's a multiple of 5, and I know that by the fact that it ends in a 5. So that 9 is no use to me. What's my next prime number? 11. What do I add to 11 to make 24? Oh, I add 13, which is next to it. So that's my next pair, 11 and 13. So I've used the 11, I've used the 13, I've already used 17 because that went with 7. I've already used 19 because that went with 5. 23 is a prime number. Now, some of you might have thought, I can use that. 23 add 1 makes 24. But 1 is not a prime number, because the definition of a prime number is a number that only has 2 factors, 1 in itself. And obviously 1 only has 1 factor. So I can't use 23 either. I hope you didn't write 23 and 1 as one of your answers, because it would be incorrect. So my prime numbers that I can add together to make 24 are 5 and 19, 7 and 17, and 11 and 13. Question 3. Well, this is similar to what we were doing last week, because we're having to convert fractions and decimals. Put a tick in each row to complete this table. 1 has been done for you. So less than 0.75 or greater than 0.75. Now, you might want to work through these in order, starting with the second one, but what I always like to do with these is look at them and say, right, are there any that I know? Now, hopefully you can all spot half there. I know that half is 0.5, so I know that that is less than 0.75, because I've only got 5 tenths in half and there are 7 tenths in 0.75. If I'm looking at comparing tenths, there's another one that I can do quite easily here as well. If I look at the last number, 0.078, I've got no tenths, 0 in the tenths column. So although it's a longer number, it is less than 0.75, because I've got 7 tenths in 0.75. So I'm going to put a tick in less than there. So I've got 2 left to work out, 4/5 and 23/28. So I'm going to go with 4/5 first, because that seems like the easier one to start with. So 4/5, I know, and I did this a lot last week, that I can turn fifths into tenths. And the way that I'll turn fifths into tenths, into that equivalent fraction, is by doing the same to the numerator and to the denominator. If I want to turn it into tenths, I need to double that denominator, so I'm going to double the numerator, which gives me 8 tenths. And I know that 8 tenths can be written as 0.8. So looking at that, that is larger or greater than 0.75, because I've got 8 tenths. So I'm going to put a tick in that one. Now the next one, 23/28. Now I can't turn that into tenths, and I can't turn that one into hundredths. So I'm going to have to use a different approach for this one. My way of doing this will be actually to turn my 0.75 into a fraction, because then I can compare the 2 fractions. So 0.75, hopefully we all know that 0.75 is 3/4, because it's 75 over 100 and it's 3/4. So now I've got 2 fractions, and I can compare 2 fractions by putting them over a common denominator, so the same denominator on the bottom of those fractions. Now the best common denominator to do for this one would be 28, because one of them is already 28, and I can turn 4 into 28 by multiplying it by 7. And yes, we all know that if I multiply the denominator by 7, I need to do the same to the numerator. So what I'm going to do is multiply 4 by 7 to get 28, and 3 multiplied by 7 gives me 21. So I'm now comparing the fractions. I've got 23/28 and I've got 21/28, which is my 0.75. So the 23/28 I've been asked to look at is greater than 0.75, because that's 21/28. So my tick for this one is going to go there. So that's day 3. Thank you for listening to day 3. I'm hoping my visitor is going to come and join me on day 4, and I'll see you tomorrow on Thursday.